Okay. Remember, I would like to give you a chance tomorrow. Tomorrow I want to make a dedicated makeup testing, right? Okay. Yes. Okay, you won't be here. Okay. We'll do another one in 2 weeks from tomorrow too. Okay. I may pull people in for TA to do this a little bit too. Okay. Don't ignore the requests I'm sending to TA for the next couple of days. I'm gonna do a little review in here of Chapter 5 stuff. So a lot of I requested like
Holla at me.
50 people.
If you request me all this week, Miss Jensen's been the sub for help, and Mr. was needed.
Okay, so just know that you are, if you don't have a C or better in the class right now, you are definitely requested for the next few days. Okay, so just check your grades and you'll know. Okay, all right. So here's what I want to do then. The big part of this unit we're doing, which is Chapter 6, Unit 5 is Chapter 6. All the stuff we've done up till now, I mean, some of it's important, but this is really the big topic that is most of the work in the whole chapter comes from this section. Okay, so we're gonna break it into pieces. But what I'm trying to do is I want to just tailor this so we're gonna take a test at the end of the year. Do you guys know about this? We're gonna take, no kidding, and I'm being straight up honest with you here. This is easier than Chapter 5. It really is. The stuff we're going to do here, the kind of factoring we're going to do here is not as difficult as what you did in Chapter 5. I believe that. I think Chapter 5 every year, even though I think if you went back at the end of the year and did problems from every section, you'd think that the Chapter 5 stuff wasn't as hard as you thought it was at the time. Chapter 5 is always the area where students have the most trouble because it's the first time you do really hard stuff. Okay, solving polynomial equations, though we've already done this. Polynomials, remember, quadratic functions and quadratic equations are polynomials. So you already know how to solve some of these. For example, how would you solve, let's just review real quickly how we do this. How would you solve this one? What if I told you, let's see, we had, okay. What's the problem with that makes it harder than some of the stuff you did in Chapter 5? It looks pretty similar, but if this were, for example, if that were an x squared and that were an x and that were just a plain old 4, what could we always do if we wanted to? Quadratic formula, right? Okay, the problem here is that's a cubic equation. Right? And so there is no cubic formula. We can't just throw that into a formula and be done with it. Okay, what we have to do here is the stuff that we started off in Chapter 5 doing. If you go back and you think about the progression of the learning you guys did in Chapter 5, remember that for most of the first part of the chapter, we didn't have the quadratic formula. When we wanted to solve a quadratic equation, we did stuff like this, right? I could have given you this one. What if we said x squared plus 5x plus 6 equals 0? If you don't have the quadratic formula, how do you solve that? And I know that you've gotten pretty used to the quadratic formula, which is fine. It works. But there actually is an easier way of solving this than the quadratic formula. Remember what our first and best strategy always is if it works? No, that's pretty hard. We won't ever rely on that. It would work though. What was it? Factoring. Factoring, I know people kind of associate people just want nothing to do with factoring because they remember the hard factoring. And I get it. We don't, like if this had let's say it had a 7 out front. Oh, we would, for sure, we're just going to put that in the quadratic formula because factoring that would be very difficult, if even possible. We'd have to do the dreaded A times C then split B stuff, right? We don't want to do that if we can avoid it. So if A is ever not equal to 1, we always just put it in the quadratic formula and get an answer, right? But what if A is equal to 1? Like that. Then if it factors really easily. And so we can always check real quick to see if it does factor, and if so, take advantage of it. If not, fall back on the quadratic formula. For this to factor, what do the magic numbers have to do? Multiply to what and add to what? Okay, good. They multiply to 6 and add to 5. Are there numbers that do that?
Yes.
3 and 2. Now that's a lot easier than having to go through the whole quadratic formula and simplify it, right? If we can just break this apart into x plus 3 times x plus 2, now what are my solutions? -3 and -2, right? Because then all we do is we apply the zero product property. If we can factor a polynomial, then we can just set the small factors equal to 0, and that's easy, right? That we're trading the big equation for small, easy ones. So the solutions would just be then, when does x plus 3 equal 0? Well, when x equals -3. When does x plus 2 equal 0? When x equals -2. Done, right? So that's always a good strategy if it's easy to do. We can factor and then set the factors equal to 0, which we call the zero product property. Now, that's a nice strategy to apply when it's convenient in Chapter 5, but in Chapter 6, that's the only way, because we don't have a formula we can just dump stuff into. So we have to factor this. But what's always if we go back to our factoring stuff too, and we're a little out of practice, so we haven't done that for a while, what do we always try to do first when we're factoring something? We always want to try to simplify things by doing, before we get into like trying to break things apart into big pieces. So ignore the 0 for a second here. What do we always want to try to do first? We always want to see if we can factor out a, what? Yeah, greatest common factor, right? Is there something we can undistribute from all the terms that'll make what's left over easier to deal with? So I can take a 2 out, right? So I could take a 2 out. Now, what about the variables? Can I undistribute any x's? Can I undistribute a power of x?
2x.
I could take out an x to the 1, couldn't I? So I could take out a 2. Oh. There we go. I could take out a 2x, couldn't I? How come I can't take more? How come I couldn't factor out like an x squared? Oh, okay, because this last term only has an x to the 1, right? So it couldn't give away an x squared. Does that make sense? I can only factor out the smallest common power of x. So I can factor out a 2x. Now what am I left with if I undistribute a 2x? 2x times what is x cubed? X squared. 2x times what is 2x squared? Okay, so I'm going to do a minus x, right? And then 2x times what is -4x?
-2.
Okay. Okay, now look what we did. Now we've got this thing broken apart into factors, a red factor and a blue factor. Each one of those factors by themselves are easy to deal with, though, aren't they? Right? I could, at this point, do I even have to factor anymore if I'm trying to solve this thing? How come? Okay, Chuck, you're right.
Yeah, in the middle, and you just do the factor and
Okay, well, what about the red one? What's the answer to the red one? If we just stopped right here, if I set the first factor equal to 0 and solve, what do I get? X equals. So, in other words, if I set 2x equal to 0 and divide both sides by 2, I get 0. Okay, probably an easier way to think about that is, say, what value of x would I have to plug in to make that 0? Well, 0, right? Okay. What about this one, though? It turns out it does factor. But what if it didn't? It may not factor. How could I find the zeros of the blue one? Now, all I'm going to do is set the blue factor equal to 0, which is going to look like x squared minus x minus 2 equals 0, right? How can I solve that equation? Isn't that just a quadratic equation in standard form? So what's my ace in the hole? Quadratic formula, right? If I have ax squared plus bx plus c equals 0, then I know x equals negative, right? So on and so forth, right? Okay, so I could do that. I could just plug this into the quadratic formula. Okay, does it factor? Are there magic numbers that multiply to what? What do they have to multiply to? -2 and add to -1. Do those numbers exist? -2 and +1. Yeah, so that's even easier, right? We could just break this apart into x minus 2 and x plus 1. And then I probably shouldn't have done this yet. Out front, we would have the 2x, and now I've got this thing broken apart into really small pieces. And so it's easy to get the zeros, the solutions, right? I get x equals 0 or x equals what? What's the value of x that would make that 0? 2. How about this one? Right? Okay, is that the idea? Okay, so what we just did there, the idea is if we can just break these things apart into small enough pieces, by setting the pieces equal to 0, the factors equal to 0, we can get the answers. Now, what's our goal then? We actually just did a chapter 6 problem. This is a cubic polynomial equation that we just solved, right? But we turned it into a chapter 5 problem really easily. By factoring out that 2x, we ended up with each of our pieces, each of our factors being quadratic or even smaller. And if I can get the factors down to the point where they're quadratic or smaller or linear, then by setting them equal to 0, I can just always use the quadratic formula. But that's got to be my goal in chapter 6 then. I've got to be able to factor these polynomial expressions. I've got to break these polynomials up into pieces that are at least that small, quadratic, and then I can just use the quadratic formula if I choose, right? So that's the challenge we've got in chapter 6. Okay, so let's so let me skip this. Okay, so here's the first part. Yes, sir.
Can I go to the next one?
Oh, yeah, go ahead. Good luck. Now, this ends up being a pretty easy chapter to deal with in a way because we can break it down into 3 parts, the stuff we're doing right now, factoring polynomials. We're gonna learn how to strategies for factoring polynomials with 2 terms, 3 terms, and 4 terms. And they each have their own different separate strategies. So you can break it into nice convenient pieces. We're going to start off looking at just 2 terms. So what happens if we have polynomials with 2 terms? So for example, if I wanted you to factor this. Okay, that's a 3rd degree polynomial, right? Cubic polynomial. How could we do that? Right? How could we factor that? Well, that's what we're going to talk about. Okay, here are some special factoring patterns. Okay, sum of cubes and difference of cubes. And I'm going to add to that one that we had from chapter, actually 2. One of them that works and one of them that doesn't work, that we had from chapter 5. Okay, in chapter 5, you might remember, this is a really easy one. So there's only 3 of these things you have to remember, and that's it. And I'll show you how to remember them too. There's a way you can remember them that makes them really simple. In chapter 5, we also had a difference of squares. Do you remember how this factored? A squared minus b squared. How did that break apart? A squared minus b squared always broke apart into what? Remember? I wouldn't blame you if you didn't remember because we didn't do it very often. Because we were able to solve these by isolating x instead, so we really never factored them. But do you remember us saying that a squared minus b squared factored into a plus b times what?
No.
Why is it doing that? Times what? A minus b. Difference of squares always factored into a plus b times a minus b. And what about this one? And I'll tell you in advance, this is a trick question. What about a sum of squares? What about a squared plus b squared? No, this is a trick one. Yeah, it's a trick one. This one doesn't factor. You can't do anything with it. So if you ever get something that would fit the pattern of a squared plus b squared, you're done. It doesn't factor, okay? Okay, so let's look at these patterns, see if we can see how to remember these things. Okay, sum of two cubes. Now look how this works. If I'm going to do the sum of two cubes, a cubed plus b cubed, and the difference of two cubes, a cubed minus b cubed, the patterns are almost the same. I wanted to show you how these patterns work. Okay, they both break up into a small factor times a big factor. Okay, the small factor is really simple. The two terms in the small factor, in both cases, are just, I keep doing that, it's driving me crazy, are just a and b. Okay? We'll put the signs in later. In the big factor, now the small factor is linear, the big factor is quadratic. And so in the big factor, we're just, the three terms are just the three different ways that we could combine a and b and get an exponent of 2. So I could just have an a squared by itself. I could have an a to the 1 times a b to the 1, or I could have a b squared, right? Does that make sense? You see so far how this thing is built. Okay, we got a to the 1, b to the 1 in the first factor, second factor, a squared, ab, b squared. Now let's fill in the signs. Okay, signs are also really simple. The way the signs work. Whatever the original sign is, so if it is a sum of cubes, then whatever the first sign is the sign that appears in the operation that appears in the first factor. So a sum of cubes always starts off with a plus b. A difference of cubes always starts out with a minus b. Okay, the next sign is always the opposite of the first, so you switch. Okay, so I go from a plus b to a squared minus ab here. Down here, that becomes a plus. Okay? The last one is always positive. So this one is always the same. And that's the patterns. That's it. So it's not that hard, is it? You can remember that. Okay? So let's try that. Fill in the blanks for me. We'll do minus first. Okay. Without looking, turn your notes over, see what we can do here. Who am I going to pick on? Who am I going to pick on? Scott, see if you remember this. A cubed minus b cubed. What's the first factor? A
Plus b.
No. How come? It's always the same as the original, right? Whatever the original is, the first one is the same. Okay, second factor, Tim, go. Okay, it's plus. Yeah, what goes first there? Do you remember? A squared. Good. Plus. AB. Very good. What's the last one? Somebody help me out. Plus. Always plus. Last one's always plus. Okay, makes sense? Okay, how about this one? First part? A plus B. Good. Second part? Minus AB plus B squared. Good, you got it. Okay, so now what do we do with this? All right, so these patterns. Now, why are we learning these things? Okay, they save us a ton of time. Here's what they do. Let's start off with a difference of squares. Okay, we'll start easy. So with the difference of squares, and what's that one? A squared minus B squared. This is an easy one. This is from chapter 5. Remember? What is that one? A plus B. Good. Times A minus B. Okay, so this is the one that applies if we ever have two terms that can be written as something squared minus something else squared. For example, what if I had something like x squared minus 49? Can that be written as something squared minus something else squared? Yeah, wouldn't that just be x squared minus 7 squared, right? So if that's x squared minus 7 squared, what's the answer going to be? If I fit that pattern. So my a is like an x, and my b is being replaced by a 7. So what's the pattern? A is x, right? Plus b, which is 7, times a, which is x, minus b, which is 7. Done. Okay, see how that works? Okay, let's practice some more. Try this one. How about okay, which pattern, if any, could that one fit of our 3 patterns? Difference of, okay, it's the difference of squares, isn't it? Because I've got an x squared in it. Does everybody see that? Everybody see this one does not fit a difference of cubes because the x isn't being cubed, right? So the only possibility is this one. And what's that equal again? A plus b.
Wait, which one is the trip one? Is that a squared plus b?
That's the one that doesn't work. Yep. Okay, so now we got to figure out what's my a and what's my b. Can I write this? Here's how I like to do this. I always like to write it like that, and then see if we can fill in the blanks. So what's now the b is pretty simple. What squared is 100? 10. So b has got to be replaced by a 10. Now the a is a little trickier. 3x. Everybody see that? It's got to be a 3x because when I apply the properties of exponents here, if I square 3x, doesn't that mean I have to distribute the squared to both parts? 3 squared is 9 and x squared is x squared. You get that? Okay. So that's my a and that's my b. So what's the answer going to be then if I fit this pattern? What does a plus b look like? Yeah, 3x plus 10. What does a minus b look like? Done. How about that?
That was hard.
Okay.
Why is there a b squared?
Oh, I'm sorry. That's a mistake. Sorry. Right there. Sorry. Okay, make sense?
Why is it plus versus subtraction?
Doesn't make any difference which one you put first. You can do the minus first if you want to. Because it doesn't, when I multiply 2 factors, the order doesn't really matter. So I could put 3x minus 10 first and 3x plus 10. If you prefer that, if that looks better to you, do that. That's fine. Either way. Okay? Another one. How about x cubed plus 8? Are there any of our patterns that could fit? Now, what are our patterns again? The 3 of them that work. Difference of squares we just did. What are the other 2? Difference of cubes or sum of cubes. Is that a difference or a sum? Sum. And it might fit cubes, right? Because the x is cubed. So the question is just, can we write this as something cubed plus something cubed? If we can, it's going to fit this pattern, right? Okay, so what's our a going to be? X. What's our b?
2.
Okay, good, because 2 cubed is 8, right? Now, cubes, knowing the perfect squares and the perfect cubes is helpful. It really is, which is precisely why I'm going to give you a memorization assignment over knowing all of your perfect squares through 20 and all of your perfect cubes through 10. That's very useful to know, I promise you. That counts for free points on college tests.
Is it going to be a test or a division test?
It's gonna be like just a little memorization quiz, like what we did
Oh, dude,
last.
so I was gonna bring my grade up a little bit?
Yeah. I'm gonna give you an assignment first, so to practice. But then we'll take a test, memorization
Get
test.
at me with it right now.
Okay, so what's our pattern for a cubed plus b cubed again? It's been a little while. How's that factor?
A plus B.
Oh, and then
A squared plus
Uh,
minus B plus B squared.
Okay, good. So now we know what our a and our b are, right? So all we have to do is fit that pattern. Okay, so we end up getting, what's a plus b,
What? Dude, yeah, I'm done.
right?
X.
Okay, what's a squared?
Uh,
What's ab?
2x.
2x, right? X times 2 would be 2x. And then b squared?
Plus.
Yeah, b is 2, right? So what's 2 squared? That's it. Okay. Now you might be asking the question, I hope you are. You might be asking the question, could I go further with that? Because if there's a question in Moodle that asks you to factor completely, you have to factor until you can't factor anymore. So the question is then, this one's done, right? Because it's down to just an x to the 1. But this one, could we go further because it's quadratic? And the answer is no, you never can. And I'll tell you why. This is good news. Why can't you? Because whenever you use these patterns, the sum of cubes or the difference of cubes, the quadratic that you get, either there or there, those quadratics are what we call irreducible quadratics. They will never factor any further. So don't even bother trying because you're just wasting your time. They never will. Okay, they're always just done. When you apply the pattern, you're done. Which is good news. That makes things easier. Okay? Okay, so how about, let's try this one. What if we have, okay. Are there any of the patterns that this has a chance of working with?
I don't know when squares.
Well, I don't care about, don't worry about that yet. Right now, I just want to know, is there potential for this to fit any pattern? Which ones?
No, just kidding.
Which one? Difference of cubes, right?
No,
Difference of cubes is the only possibility. Everybody see why? That's an easy question. Because I have an x cubed minus something, right? So the only one this could potentially fit is a difference of cubes.
I feel like it's
So the question is, can we write this as something cubed minus something cubed? Now remind me real quick, what is the difference of cubes pattern? A cubed minus b cubed equals what?
A minus B
Times,
squared plus AB minus
no, always end with a plus.
Yeah.
Okay, so will this potentially work?
Yes.
Okay, yeah, now the second one is a big number, but you're gonna know those pretty soon. 729 is the perfect cube that goes with 9. That's 9 cubed. The cubes get big in a hurry, don't they? Yeah. So this is just 9 cubed. B is 9, right? What about the A? 3x, right? Good.
That's the square.
Okay, why is that? Because 3 cubed is 27 and x cubed is x cubed, right? You see that? Okay, now watch this one closely because this isn't hard, but there's a very common mistake that people make when they try to fill in the template for this one. A is 3x, B is 9, right? And I picked a bad one here. I don't want to confuse you. I'm going to do something a little different. Let's do, hang on a second. I'm going to do, sorry if you have to change your notes, but you'll thank me for this. We don't want to. Okay, I'm going to pick a little different one. I'm going to pick instead 512, which is 8 cubed. Okay, so B is 8. Okay, so A is the quantity 3x, B is 8. If I follow this template then, what is A minus B? A is 3x, B is 8. So far pretty easy, right? Okay, now what about over here? What is A squared? No. Okay, what do you mean by 3x squared? Is this right? Tell me if this is right.
No, 9x.
Ah, okay, good. Because it's not 3x squared, it's the quantity 3x squared. A is the whole 3x, right? It's 3 times x, the whole package. So when I square A, I have to square the quantity 3x. That's the most common mistake, in my experience, people make on this. Okay, AB is not a big deal. AB is just going to be 3x times 8, right? And then B squared is just 8 squared. So what does that all simplify to? So we get 3x minus 8, sure. What about in here? What is the quantity 3x squared? What is the,
9x.
yeah, I gotta square the 3 and the x, right? So it's a 9x squared, 3x times 8,
24x.
24x, and 8 squared, 64. Done. It's not that bad, is it? It's not that bad. I mean, it's the same pattern over and over again, right? Okay, it takes a little practice, but it's a little bit of practice. You'll be amazed how quickly you'll think, wow, I got this. This is not that big a deal. Okay.
I love it.
Okay, real quick, what would my A and B be there? What's the pattern? Sum of cubes, right? What's the pattern? 3x. And 10. Just apply the pattern, you're done, right? Okay, so next issue, and now think about this. That's 1/3 of the hard part of chapter 6 in my mind. Not too bad, really. Comparatively, not that bad. You're not having to complete the square. You're not having, really, this is easier. Okay, this one you already know. You already know how to do this. The second of the 3 strategies is how do we factor a polynomial with 4 terms? You've already done this. This is just a part of it. Remember when we learned how to do 8 times c then split b? We don't like that.
No.
Okay, but most of the problem with 8 times c then split b is not the factoring part. It's the finding the magic numbers part. That's the harder part, right? We don't have to do that. This follows the same pattern though. Do you remember that when we did the 8 times c then split b stuff, when we factored quadratics where a was not equal to 1, we factored by grouping is what we called that. So that's our strategy. When we've got 4 terms, we're going to factor by grouping. And here's all we do. When we factor by grouping, we're literally just going to make a group for the first 2 terms and a group for the second 2 terms. And we're just going to follow a pattern. Okay? So the first 2 terms are just x cubed minus 2x squared. The second 2 terms are negative 9x plus 18. And you might remember how we did this. Do you remember that when we did the 8 times c then split b, our goal here was we were going to factor out the greatest common factor. Remember that? What is the greatest common factor of the first group?
X.
X squared, right? Everybody agree I could undistribute an x squared? Okay, if I undistribute an x squared, what's the leftover? In other words, x squared times what is x cubed?
X.
X. X squared times what is negative 2x squared? Right? Everybody agree so far? With that? Questions?
Golden point.
Okay.
Like a.
All right, so now the second part, that's we're most of the way done. The second part, if this is going to work, and let me preface this by saying that, of course, on the assignment, I have created some problems that mostly work, right? I may throw in 1 or 2 every once in a while that don't work, just so you can see, that it doesn't work. But mainly, we're practicing ones that do work. They don't have to, though. If this process doesn't work, we're done. This is the only technique for factoring 4-term polynomials that I am going to teach you. And the other ones are pretty bizarre, and we're not going to mess with them. So if this didn't work, your answer would just be it doesn't factor and you're done, okay? But if it does, here's what has to happen. Remember that when we break the second group apart up into a greatest common factor and a leftover, which one of those two factors, the blue or the red, has to be the same? Nope, the blue. Remember that the blue, whatever I get from my leftover here, now watch closely, you're going to miss this.
Yep.
Whatever I get from my leftover here has to be reflected in group 2. It has to be the same. So we don't know that it's going to work yet, but if it does work, that has to be an x minus 2. So then the only question remaining for us is just, does it work? Could I undistribute something to get an x minus 2 in the second group? What would it be?
That would be -9.
Everybody agree?
Yeah.
Okay, there's an easy way to tell. Now watch the strategy for this. It's really simple. If I want to know what's going to go here, the easiest way to do it would be to say, well, what times x is negative 9x? It's negative 9. But it also has to work on the second term, so I'll just check. Negative 9 times negative 2 is 18. Check. It worked. Okay? So if it works, if we can find, if factoring by grouping works, then what does this become? Well, I've got, look at this, I've got a red and a blue factor in my first group, a red and a blue factor in my second group. The blue factors are the same, so I could undistribute them, right? I could undistribute the whole x minus 2 from each group. What am I left with if I do that? Yeah. Oh, what was that? I'm left with just x squared minus 9, right? Okay, done. Where am I? I'm done with the grouping part. Can I go any further?
Yes. Can't you just count the
Now, I don't want to multiply them out because I'm undoing all my hard work. But can I break them apart any further? Well, the blue one's obviously done because the x is to the first power. But the red one is quadratic. Can I go further with the red one? Now, how many terms are in the red one? 2. So if I'm factoring something with 2 terms, the only way we do that is with the patterns. Does that fit any of the patterns?
Nope.
Oh, yeah, you said A.
Ah, that's a difference of 2 whats? No, the x is squared. Difference of 2 squares, right? So does this fit the pattern? We have to just ask ourselves, does this fit the pattern? Can I make that fit the pattern? A squared minus b squared. What's A? What's b? 3. 3 squared is 9, isn't it? Right? So this breaks into x squared minus 3 squared, right? And how does that, what's the pattern for a squared minus b squared?
A plus B times B.
Exactly, right? So a is x, b is 3. So I'm going to get a plus b times a minus b. Now Selena's going to do that the other way. She likes it the other way. That's fine. That's fine. She can do that. And then we have that x minus 2 out front. Now we're done for sure. There's no way we could go any further than that. Make sense?
My name's Amber.
Okay. Try one more of those.
She's like, what?
Okay, try that. Get out your notebooks. Come on now, try that. See if we can. Factor by grouping. Can you do this once now, or I'll come back to you when you're doing your assignment? Who wants paper? Anybody want paper?
Yep. Yeah,
Paper?
oh, never mind. Got some.
You got paper back
I
here?
only need one.
How many in this row? 2? Looks like 2. Melissa, do you need these?
Yes.
Okay, another one.
Yes, please.
Right here, all right, there we go. Okay, right there. Okay.
I freaking know, it almost.
Okay, you try that while I take roll. Okay, so what's our strategy? What do we call this? What's our strategy for factoring four-term polynomial? Grouping. Good. Grouping. Good. Okay. So there are my groups, right? Two groups of two. Okay, what's first? Which group do I start with? First group. Okay. What's the greatest common factor? 10x squared. Good. Okay, do you have questions on that? Anybody not sure why that's the case? Everybody okay with that? 10 is the biggest number that goes into both 10 and 20, and x squared is the biggest power of x, biggest common power of x, meaning of those two terms, each of them have at least an x squared, right?
Yep.
Okay? Okay, what's left over if I undistribute that?
So X.
Everybody see that? Plus 2. Okay, good. Oh. All right. So remember to have your reviews ready to go for tomorrow.